The Japan Welding Engineering Society offers welding technique examinations and certification. Semi-automatic welding skill examinations are classified according to plate thickness, welding position and presence of backing metal, for example, with a certification for each class. These technical certification tests are comprised of a written test and a practical skills test. The practical portion is evaluated by a visual inspection and a bend test. The completed test piece is visually inspected by a judge, and if it passes, a bend test is performed. Let's take a look at the work procedure step by step for butt welding a medium thickness plate in a flat position with backing metal. First, remove the mill scale from the top and bottom of the workpiece and from the backing metal. Next, to fix each part of the test piece in place, tack weld both ends of the groove face to the backing metal. This maintains the prescribed dimensions for the test piece and prevents distortion and weld defects during the welding. The root opening should be 4 to 5 millimeters. Make sure that there is no gap between the workpiece and the backing metal, that the root opening is within the prescribed dimensions, and that there is no significant difference between the two ends. After the tack welding, use a reverse strain gauge and make a preset distortion of about 3 degrees. This will counteract any distortion in the workpiece after the welding is finished. To prevent weld defects, make sure that no oil, paint, moisture or other foreign matter adheres to the surface of either the workpiece face or the groove face after the tack welding, and also watch out for rust formation. Next, check the shielding gas flow rate. Combined with a proper wire extension, set the welding current at 200 amperes and the arc voltage to 24 volts. To set the voltage, don't simply set the meter, but check the arc and adjust the voltage so that the arc length is just right. Begin welding. For the first layer, hold the torch at the correct angle for a backward draw. Hold the wire tip at the start position for the welding and ignite the arc. When the weld pool becomes wider than the root opening at about 6 to 7 millimeters wide, draw the torch backward while maintaining a 10 to 30 degree angle. How about this welding start? The torch motion appears to be too fast. If you start moving before the weld pool forms sufficiently, the beads will not spread out or build up enough, and there will not be enough penetration. To prevent this, a scrap plate is often used. With this method, the scrap plate is set off to the side of the weld starting point, and you start the weld on the scrap plate. How is it now? The beads spread and reinforcement are fine. Let's start again from the beginning. The welding will be done in 3 layers with 3 passes. For the first layer, the backward draw method is used to ensure sufficient penetration. When the arc becomes stable, aim for the centre of the groove opening, hold the torch at a reverse 20-degree angle, and weld using a semi-weaving technique with the wire tip zigzagging 2 to 3 millimeters. Aim the wire tip at the groove root and weld pool side and make sure it melts the groove root face well. Also be careful about your welding speed. If it's too slow, the edge of the weld pool builds up and the weld pool extends ahead of the wire, resulting in shallow penetration. While welding, keep a close eye on the shape of the weld pool and make sure there is no deviation to one side, that the bead stays straight and doesn't build too high, or that the bead end does not sink. This is the finish point of the weld. Here, if you simply cut off the arc, a crater will form in the bead face. A crater left like this will cause weld cracking and ruin the bead profile, so always fill in the crater. There are two ways to fill in a crater. One method is to stop the motion of the torch at the finishing point and strike the arc over the crater a few times for a half second to full second each time. This allows the weld pool to cool and fixes the dent while preventing burn-through of the weld metal. The other method is to stop the motion of the torch at the finishing point and move it slightly side to side over the weld pool or in a circle to fill in the dent. This should be done about 7 to 8 millimeters in from the end of the workpiece. It's also possible to combine the two techniques. Thoroughly remove the slag or spatter from the first layer. For the second layer, use the forward push method and weave from the end of the first layer bead. When weaving the torch, pause briefly at both sides to allow sufficient penetration between the first layer bead and the groove face. One other point to be aware of when welding the second bead layer is to keep the outside line of the weld pool 1 to 2 millimeters below the groove face. This will create a clean finishing layer. Clean the surface of the second weld layer. For the third layer, use a forward push method, weaving side to side the full width and finish in one pass. The bead width should be wider than the groove width by 2 to 3 millimeters on each side, and the weld reinforcement height should be about 2 millimeters in the center of the bead with a gently rounded weld reinforcement. To avoid undercuts on either side of the bead width, move the torch slowly. Weaving that extends beyond the groove width can cause uneven bead width, so be sure to stop before you reach the groove line and allow the spreading of the weld pool to melt the groove edge. At the finishing point, fill the crater and be careful to avoid burn-through or insufficient weld reinforcement height. This completes the job. Let's look at the weld now. The bead has a uniform width and is formed continuously. Next, a bend test checks the mechanical properties of the test piece. The test bar is bent 180 degrees into a U shape to check the soundness of the weld. Let's see the result. It's a sound weld. These are examples of defects, cracking and breakage. Welding defects can arise from a multitude of causes. There are ways to handle individual problems, but the most important thing for the welder is to keep faithfully to the basics in every step of the process, applying close attention from preparation to finish. Welding skills are needed throughout the manufacturing industry. Master the things you have learned today and pass the welder's certification test.